Hi everyone, thanks for coming this afternoon. And I also really appreciate who's still here because every day at this time is always the time that you look at your watch frequently, right? Yeah, but today we're gonna give you a really, really good appetizer for your dinner. And we have 5 people here and they're gonna introduce the entire process, design process of the Rokid Glass through the whole process. So my name is Gonglue Jiang, and I'm the chief designer of Rokid. And 3 years ago, we started to design the Rokid Glass. And after 3 years, right at this month, we are in mass production. So it's really a milestone for the AR glasses. If you're in the industry, you're gonna know how hard to really mass produce AR glass. And so through the whole 3 years process, there's a very, very few reference we can refer to design the entire AR glasses, including the hardware and software. So this is really a good opportunity. We can share all the outcomes and all the experience in the past 3 years. So this is the first time. So we think this is a really good opportunity. We can share everything to you guys. Little about Rokid. We established in 2014 and based in Hangzhou. And 2016, we established the branch in the Silicon Valley and mainly focus on the AR and AR glasses, hardware and software. So this is still not fixed, right? Okay, sorry, this is a very bad animation, so you have to wait to the end. Okay, so Rokid started, why the company started? They started because they believe AI technology can revolve the entire HCI industry. There will be a revolution of the HCI, human-computer interaction. So why? Let's just take a look back a little bit. Like at the beginning, and people use the command line and keyboard to communicate with the computer, right? And later on, the revolutionary GUI, they can communicate with the graphics. And later on, people can use their natural gesture to communicate with the computer. And even the 2-year-old kids can control this, can master this very easily, right? So the trend is that it's getting to more natural and intuitive. So in the AI era, the AI technology can recognize the natural language, and that's the revolution, right? But on the other hand, there's another revolution. The computer can understand everything around us, but there's no product for that, right? Before that, there's a product like Amazon Echo and Google Home, but here, this is AR glasses will be the best carrier for this AI technology. That's our belief. So at 2014, we developed a series of smart speakers like Amazon Echo. So we are the counterpart of the Amazon Echo and the Google Home in China. And later on, in 2016, we developed our first AR glasses. And at this month, we mass produced it. So that's our principle to develop the AR glasses. Start from human-computer interaction. It's a different approach. As you know, like there are some many companies, they started AR glasses because they have optic technology or they have SLAM technology, but we have the AI technology. So we started from a different approach. And that's how we're different from others. So we're gonna introduce that later. And one advantage we see of the AR glass is that it can see what you see, right? Because if you want the computer to understand the environment around you, you have to hold your phone, right? But you have to make some effort. But with the AR glasses, it's wear on your head, and you don't have to make any effort. So the computer can see what you see and can analyze and understand the environment around you. And also, that's the best position for human-computer interaction, especially the personal HCI, because it can show the ubiquitous GUI anywhere, right? Because you don't care any GUI display outside your vision, right? And also for speaking, because we started from the voice, And we also have some discussion on the personal natural language devices. You know, everyone already get used to the Amazon Echo and Google Home in their home, right? But there's not a good or very convenient device on your personal, right? Because the Siri has been developed for 6 or 7 years, but no one use it, right, for your daily life. And watch and the earphone, and I think it's really, really low frequency of the usage. But for the AR glasses, that'll be open another era of the natural language communication, because whenever you speak anything, it can understand. You don't have to do any effort, the effortless VUI. And also the mixed reality sound. So you don't have to wear any earphone or headphone and to block the sound outside. The output of the computer also mixed with the reality. So the mixed reality not only about the GUI and also the VUI, the mixed with the reality sound, and that's also really important for the AR glasses. So the way we communicate with the environment around us is like the vision, right? You see this person and you recognize this person's face, and there's a information card pop up, right? So it's really in the reality right now. So if you want to try this, and please come to the 507 booth tomorrow, and you can try this really cool feature. I know it's already banned in San Francisco area of the facial recognition. There's a legal notice just announced last month or something. But I believe this is also a really useful feature, especially for the security and the safety of the community around us, right? And also the voice recognition. So these two interactions is the way we communicate with the computer without any effort, right? It's just like very, very natural. And we also have other way to communicate, right? Like a touchpad, like a Google Glass, and also the head gaze. And you use the head gaze to select the menu on the UI. So we call it XUI because it's not only GUI or VUI or touch UI, it's everything mixed together on this device. So we call it XUI. So we have to consider the scenario, the using scenario, not only the GUI, right? Because when I be a designer on a mobile phone, you only consider the graphics UI. But right now, we consider everything around us. So we do AR, it's not because of AR. We do AR because it's the best carrier for AI and HCI technology. So that's our ground. And I will introduce a little bit about industrial design, right? So whenever people design AR glasses, the first come will be industrial design. And at the beginning, we'll just go back a little bit, like what's our design DNA? What's the Rokid design DNA? So that's the, as I said, we started from the smart speaker, and these three are our smart speaker series. And the biggest one is called Alien, right? So if you look at these devices, what's the feeling of it, right? The feeling is that it's not look like some traditional black box electronics, traditional electronics, right? It looks like something living in the future. So in the AI era, right, because there's an AI engine inside it, and the way people communicate with that is totally different. They like communicate with a friend, like a person. So we want to design it something not look like electronics. We want to make it some like a creature. So that's our design principle. And also, we have to start it from optics. And everything around is optics. And we use the freeform, really challenging freeform, the optic solution. And we have the highest energy efficiency in the industry for this one. And but you can look at this. The shape of the lens is really like a sphere looking, right? So how to decrease the sphere looking effect is the key to the industrial design. And also at the beginning, we established this prototype. And we have the mission of industrial design is to have to fit this one into a very small and sleek design. So this is our final ID design. And the battery is on the back. And also it can fit your head very perfectly and it's really tight on your head. And it's whole body streamlined design. And you can feel the same thing as you see our previous product, where we want to make it is really, really sleek and stylish design. And on the side is really slim. Yeah, everything we have to make it is the smallest size and the lightest weight. And the looking, right, we decrease the effect of the optics and we only have one lens. A lot of AR glasses, they have 2 lenses and 3 lenses, right, because they are cover glass. So we use this functional lens as the cover glass. It's only 1 layer of lens. So that's make this glass more look like a sunglasses. And this is how people put it on. Yeah, looks handsome, not because this guy looks handsome, it's just because, yeah, the glass really look like a cool sunglasses when you put it on. So our principle is to design it unobtrusive. Because there's a little story to share with you guys. 2012, Google launched their Google Glass, right? But I worked at Google back then, and I had a Google Glass back then, and I wear it at the beginning. I wear it every day, but I feel that I have to take it off when I get in the bathroom, right? Because people won't let me in. And I have to take it off when I get into the movie theater because people won't let you in. And just one day, I walk on the street and some people said, oh, that guy wear a Google Glass, just to be away from him. And at that time, I feel that this glass have the biggest problem is because it's intrusive. And people think there's a camera and maybe you are filming, hiding somewhere, right? Because if you hold a phone, it's okay, people know it. But at AR glasses, people won't know it, so people will feel unsafe. So that's our design principle, to design it unobtrusive. It is really important, we believe, for AR glasses. Okay, so next, let's our UX researcher, Paris, to introduce the ergo design of the AR glasses, which is really important.
Hello? Hello? All right, I think this one works. Okay, cool. So, hello everyone. My name is Paris. So let's get started. So why doing ergonomic studies? Well, let me ask you guys a question first. So has any of you ever worn any AR, VR headsets before? I assume the answer is yes. I see some hands. Has it ever occurred to you why the headset is so heavy? I mean, it occurs to me all the time. So I believe that most of the AR, VR companies nowadays, they're trying to create an immersive experience for customers. And that's why they're trying to stuff all these technologies, fisheye cameras, sensors, in-depth cameras to the device. With all being added, obviously it's going to feel heavy, right? So the second point is, I believe that AR is a lot more personalized than cell phones. Well, although nowadays it could be an auxiliary to cell phones, but later on in the future, we believe that it could replace cell phones. And we envision the AR to be the future of our technology. And we don't want it to be just an add-on. We want it to be an accessory, to be something that when you wear it and go out, nobody will judge you. It's totally acceptable by the society. The third reason being that there's no existing standards, no industrial guidelines can tell you how to design or what to design for AR, VR headsets. Well, let's look at a few examples of how the AR, VR headsets are currently disturbing people's life. I use a can of Coke to represent the weight factor. As you all know, HoloLens, one of the biggest hardware. So it equals almost 2 cans of Coke. Wow. What about Magic Leap? Can you guys guess? Oh, sorry, I just popped that out. So it equals to almost a full can of Coke. What about our everyday glass, sunglasses, or prescription glasses? It only has this amount of coke. It's like about 20 to 30 grams. It's something that's so light and simple that you could wear it for days without even noticing it because it's so light. That's exactly what we're trying to do with our glasses, is that we wanted to create something that's light and simple and also comfortable for our customers. Well, see those red marks? Those are attributed by the weight and as well as the tightness of the glasses. So people can wear it for as long as 30 minutes to an hour, and those red marks will show on your forehead and also on your side of your nose. Well, how do we intend to solve this kind of problem? First, you need to understand how the glasses are structured. I'm not talking about the nitty-gritty details of how the glasses are being assembled. I'm talking about there are some key areas of the glasses that vary the weight of the glass. And also, you need to understand what people look like, how their facial features can be applied to the design of the glass. And last but not least, you need to combine your understanding of the glasses with your understanding of people's heads and facial images. Well, that's a sketch of our prototype, how it looks like. So the first key area I want you to take away is the nose pad. Well, the bigger area touches the side of your nose, the more comfort and support it gives to the user. The second point is the angle between the glass rim and the temple arm. A wide angle could shift most of the weight to the front of the glass, causing the glass to fall on your nose. And a narrow angle can shift most of the weight to the side of your head, causing the glass to fall on the side of your ears. And either of them is comfortable, as you know. So what do? We need to put equal amount of weight on the front and also on the back of the glasses. And the third and fourth point is the temple arm, the length of it, and also the curvature of it. So imagine that you have a big head. You know, sometimes you put on the glasses, and the curvature is so rigid, and it doesn't have this smooth curve, and it hurts your ear, right? So we have to make sure that when we design our glasses, the curvature is really smooth. But also, you need to make sure that the curvature has this, it surrounds your ear to provide the best support for the user. And the last point is the end of the temple arm. Usually with our prescription glasses, the end of it is usually a round tip. But with our glasses, this is our first generation. More importantly, we wanted to sit on the back of your head bones to provide the support and also balance the weight in the front. So now that we have a pretty good understanding of the glasses, what we need to do with our human beings, right? So we conducted a cross-cultural study to understand the difference between Asian and Caucasians. So this is me using a 3D camera to capture people's heads and their facial images. You don't have to. We're trying to keep this confidential, and also we turn the images into lines and shapes, so nothing personal will be reviewed. So you don't have to worry about your privacy being reviewed to the public. So this is one of the results we found with the ergonomic study. So basically, for Asians, they usually have a flat forehead and also a round head shape. Whereas Caucasians, they have a pronounced forehead and narrow head shape. So this is also correlates with one of with the results I found from a journal article I read. So after we studied the head shapes, we also analyzed people's facial images. There's a really interesting findings I had with this study. So basically for Caucasians, their nose root usually starts the same or a little bit above their line of vision, whereas Asians, their nose root starts the same or below their line of vision. So that's really interesting. And although they might have like a similar slope angle, just like the one shown on the third image. And apart from that finding, we also provided with our ID designers some key measurements of people's facial features to assist in his design. So basically, we calculate how wide your head is, also the distance between your forehead and then your pupil, and also the distance of your temple arm between your pupil and the tip of your outer ear. So this is how our ID designers are using the ergonomic data to assist in his design. So we find it's pretty useful. So, and to conclude last part of my talk, we also did some study to help us find out how much of a nose pad is really touching your nose. So basically, what we did is that we calculate amount of weight and divided it into equal portions and put it on top of the glasses. And then I made a dumpling wrapper. I don't know if you guys had eaten any of the dumplings before. It's just a piece of dough. And I put it on top of my nose. And then I have the glasses set on it to create an imprint. And later on, I wait until the dumpling wrapper dries up, and I put it inside of the fridge. And then after it becomes hardened, I took it out. And then we use a 3D scanner to capture to make a 3D copy of it. And then the last part is for us to remove all the debris and only kept what is valuable for our measurement. So to conclude, let's come back to the Coke example. Sorry, should go back. I shouldn't swear. Yeah, so basically to conclude, I'm pretty confident that we are one of the few companies that spend a lot of efforts, a lot of time on this ergonomic issue to try to provide the best wearables for our customers. And our goal and our aim is to design a glass with less than half can of Coke. And with our research is still going, we have found that I think with minimum for nose pad with a minimum touchable area of 250 millimeters, people can wear 100 or less than 100 gram glasses for at least a couple hours. And let's look at a really cool video and to see how each of the faces being stitched together to create a standardized face. I'm gonna invite my colleague Chi to talk about how he created this tool to benefit all of us. Thank you.
Oh, thank you, Paris. I'm one of the big heads that Paris just mentioned. So there's one day I look at the Paris desk, and she was working on hundreds of heads on his monitor. And this looks something like, oh, sorry, I missed my self-introduction. My name is Chi, and I'm the prototyper of the Rokid US branch. Mostly I do AR experience prototyping at the lab. So back to Paris' monitor. So it looks something like this. He's processing all the hundreds of models all at the same time. And without the experience, 3D modeling experience, it's very hard to pinpoint all the keyframes and the key structure on all of these faces. So we want to create this tool to improve the efficiency and the accuracy of our UX researcher and industrial designers' work. I want to introduce this tool called Uranus. It's a toolkit. It's built on our Rhinoceros SDK, and they use the Rhino Common SDK to process all the data and generate most of the key features and parameters for our industrial design. So people haven't seen this. So this is an artwork about how how the average face of Dutch people might look like in the future when the refugee coming to Europe. So we really wanted to apply the similar methodology to our design too, but only in 3D. But also how we do it. We broke this up into 3 steps. So first we need to process the scanning result, of course, and then we need to do a structure analysis. And of course, finally, the most important thing, we need to reconstruct the average face for our ID design. So with that model, we can have the most accurate proof or support to our to the design structure itself, and then we can have the range for the most confidence for most of the people. We can have the range. So first, when we get the 3D model, we generate a front facade of these faces, and then we run a computer vision algorithm along with it, and we can extract some of the key features, like you have seen the pupils, the head width, the eyebrows, and we put all of these features and the just curves and lines into it, and generate a 3D analyst structure like this in Rhinoceros. And once we have this, we can easily identify all the parameters and the ranges and things like a very important thing like the head width, the pupillary distance, things like that. Then we run the structure analysis onto it. When we're trying to analyze this thing and we wanted to generate the final 3D model, we have to do the section by section, plane by plane. So we use this kind of a methodology to run. So we first have this radial structure around the section we generated. Sorry, this is a plane, actually. So we have this plane analysis, and then we can easily generate the average curve of each plane. And of course, we can apply the similar methodology to the section. Once we have all of these hundreds of curves on the model, we can easily regenerate and put all the data, the point cloud into the algorithm and generate that the 3D model. Okay, finally, reconstruction. So I don't have to introduce much. Here's the real-time animation, the recording of how the software works. It slowed down like 10% of the speed, so that you guys can see the step-by-step procedure of the entire program. So here's the point cloud. And with that, we can easily generate whatever we want, and we can put our whatever the design we already have onto that model and see whether it can fit, right? Of course, the animation you have seen, we just want to be beautiful, and because we're a design team. Yeah. So we also have some extra features for this plugins. So we can generate, because we already know some of the key parameters of our hardware, like the iBox, like the FOV. So we can easily generate a very slim, very clean main structure, mainframe of our future head-mounted display product. So why we're doing this? We at our lab, we are not doing. We're doing everything. We're trying to be systematically, and we're trying to build our own infrastructure of and to support our colleagues. So I will introduce Nan and Chuqing to talk about our UI design principles, which is also very systematically. Thank you.
Hi, everyone. Yes, we are the last group in this section. Okay, I'm Nan. She's Chuqing. We are in the UX design team. Today, we are glad to introduce Halo XUI design guideline. When we start developing the glass, we were thinking that a new medium will bring new design possibilities, methods, and experience. Based on this, Rokid actually is building a platform, not a single AR product. So that's the reason we create a Halo XUI guideline as the part of our platform. We share all the design principles, visual language, and interaction with our partners and creators. When we start designing, we try to step back and thinking about the whole scenario from 3 angles. The first one is physical space. The second one is user input, and the last one is interaction feedbacks. In each perspective, we keep raising questions. For example, for the physical space, we will ask how could optic lights and ambient lights work together since they have in different light source. And after people enter the space, they wear our glass, they could interact with interface with their hands, with their eye, with different controllers. So we ask, the question is, what is the dynamic hierarchy of multiple inputs? We also ask ourselves, there are so many ways to show the information. So what kind of content we want to provide it to our user and how to merge them seamlessly. I think actually questioning and observing from these three perspectives is not only help us to get better knowledge about our user and scenarios, but it's also a good way to find the most important elements we should highlight and emphasize in our Halo X UI guideline. All these findings actually becomes the foundation of our guideline. Based on that, we divided our guideline into 4 parts. The first part is the concept. We have a lot of design principles for our creators. And we also have spatial design, interaction, and UI. This is a timeline shows the process when we developing launcher. As you can see, after the brainstorming, we have several rounds of iterations. In the first version, there is a blue panel under the test and icon. This design might work in your phone, in your laptop, in your TV screen, but after the testing, we found out this is not working when you see through the AR glass. Most of the time, it will block your user's views. So we kind of put this finding in our Halo X UI design guideline and make it like a principle to make it as a principle, so the following interactions and the project will follow this concept. So this is just a sample to show that our design guideline is a living document that will grow and evolve as we continue to explore the interface. We will launch Halo X UI guideline, the online version later this year, but Chuqing will go through some of the concept that is really interesting.
Hi, I'm Chuqing, a UX designer at Rokid. So today I'm going to talk more details about our Halo design guideline. And I'm going to start with our design principle to give you guys more idea about why we are doing this. So for the first principle, here are examples of 2 different UI style happens in our design process. So you can see on the right-hand side, it happens in the first and second iteration. As Nan mentioned before, it blocks user view and it's really not friendly. So we move to the second one. And user can see through the icon and they know what happened in the front and they don't worry about they accidentally bump into something. So here's come our first design principle. No large area of solid color is allowed, and some components need to be hollowed out in order to give user more like real world view. And our second design principle, in order to avoid conflict with the real world light source, there's no fixed single direction light source in our design environment. All the components need to light themselves up. And now I'm going to show you some examples of how we apply Halo to the UI. As you can see, the Halo definitely gives an affordance to all of the components. User know they need to take actions in these steps. And it also highlights the selected items and some important information. It leads users' attention, and the most important, as I said before, user can see through the button and the list item. And now I'm going to talk about how we are making the color system and how we are integrating this retrofuturism color style in our system. So about the color distortion, here's a chart. And I believe the color distortion happens on all the augmented reality devices display. And for our glass, the primary color of red, green, blue goes slightly lighter. And especially for the green and red, it goes a little bit yellowish. And for the white, it add a little bit blue hue onto it. So based on the test we made on the glass, and we made a decision to choose the color with high saturation, and it minimized the color distortion as much as possible. And from the aesthetic perspective, we made a rule of how to combine two colors together. The rule is there need to be two high contrast colors, and one color is approximately 120 degrees from the other one. And here's an example to show you our recommended color theme. It looks really nice on the display on the screen. It also looks nice on the glass. And by using different brightness, we are creating this halo effect. We also have 4 more different color themes for designer and developer to develop. So here's an image of how we deliver our idea of retrofuturism. And by using retrofuturism, it allows us to express a sense of sci-fi by using the neon color, and user will feel more like futuristic putting this glass on. And I believe you will have the same feeling once you try it on. Yeah, that's it. Thank you.